Hi everyone, this is Miss Rapp and we are working on Unit 6 polynomials. We are on Lesson 5, Factoring Patterns, pages 68 to 71. Let's get started. So it says solve the following polynomial equations by factoring. So this is just like our last lesson. Let's take a moment and look through this. The GCF is x, so that's 4x squared plus 16x minus 9 equals 0. So I'm going to have three answers. One's going to come from this x right here. So I'm trying to multiply to negative 36 and add to 16. And the numbers that work for that are going to be 18 and 2. And the 2 is going to be negative. So when I draw my area model, I get 4x squared negative 9, 18x negative 2x. So this is going to be 2x, and this is going to be 2x. This is going to be 2 and 1. And the 1 is going to be negative. So I have x, 2x minus 1, 2x. Oh, sorry, this should be a 9. There we go. Plus 9 equals 0. So my answers are x equals 0, x equals 1/2, x equals negative 9/2. Okay, try number 2 on your own. Okay, guys, after working through these are my two answers. Really challenge yourself and try to do that on your own because that's a review from the last lesson. Let's move on. Look at the three polynomials below that are fully factored. Identify any patterns you see connecting the factors for each, the exponents in standard form, and the coefficients for each term. Try and fill in the area model for each of the blank spaces. So let's just look at these. So this exponent is 2. This one is 1. That exponent is 0. This exponent is 4. That's 2. And that's 0. This one is 1. This is actually an exponent of 1/2, and this is an exponent of 0. Just letting you guys know as a review, I can rewrite that as x to the 1/2. So looking at these, none of these numbers are really changing. 2's and 3's, 2's and 3's, power of 1, power of 1, power of 2, power of 2, square roots. So here are some things that I'm seeing. Each term exponent goes down, decreases in a steady pattern. So what I mean by that is 2, 1, 0, 4, 2, 0, 1, 1/2, 0. Middle term exponent is exponent in factors. So like this 1 right here is the degree 1 right here. This 2 right here is the degree 2 right here. This square root right here is the square root right here. That's a cool pattern. And lastly, the numbers do not change. So those are some patterns that I see. So let's try to use this pattern to solve. So right here, I have x to the 4th plus 6x squared minus 7. Well, I'm just going to treat this like a normal area model. So I'm trying to multiply to negative 7 and add to 6. So that's going to be 1 and 7, 1 and 7. And the 1 is going to be negative. So I draw my area model. X to the 4th, negative 7. So this is going to be 1x, and this is going to be 7x squared. So x squared to get x to the 4th. You guys picking up on the pattern? This is going to be a 7. This is going to be a 1. This will be a negative 7. So I get x squared minus 1 plus 1 and x squared minus 7. When I set them equal to 0, I get x squared equals -1, so I get x equals plus or minus. I made a small mistake here. This should be a -1 right there. So that's going to make this negative. So this is actually going to be plus or minus +1. Cool. And then this will be a +7. So then I get x squared equals, so then that's going to be x squared equals -7, take the square root, and I get x equals plus or minus I root 7. Okay, let's do the next one. I'm going to take out a GCF, which is going to be 3 plus 12x3 plus 20 equals 0. So now I'm trying to multiply to 20 and add to 12, 10 and 2. So I get x to the 6, 10x3, 2x to the 3, 20. So x to the 3, x to the 3, 10 and 2. So I get x cubed plus 2 and x cubed plus 10, so equals 0. So I'll solve those. So I'm going to minus 2 on both sides, and I get x cubed equals -2. So I cube root. I get x equals the cubed root of -2. And then from the other one, I'm just going to get x equals the cubed root of -10. And that's allowed because these are odd roots, so I can have negatives. Okay, we have 2 more. Looking at this, I'm just going to start with the area model. So I'm trying to multiply to 420 and add to -52. So that's going to be 10 and 42. And then they're both going to be negative. So I'm going to draw the area model like I normally would. So notice the powers haven't really been messing us up. 7x to the 4th, 60, -10x squared, -42x squared. So from here, I could take out a 7x squared, and from here, I could take out an x squared. This is going to be a 10, and that's going to be a 6, and these are both negative. So you get 7x squared minus 10 and x squared minus 6 equals 0. So let's set them equal to 0. 7x squared minus 10 equals 0. So you're going to add 10 to both sides. You get 7x squared equals 10. Divide by 7, you get x squared equals 10 over 7. Take the square root. You get x equals plus or minus 10 sevenths, square root. And then for the other one, you're going to get x equals plus or minus the square root of 6. So it was degree 4. There are 4 answers. Cool. Okay, last one. I'm going to bring everything to one side. So I get 9x plus the square root of x minus 10 equals 0. Don't be thrown off by this. I know it looks a little weird, but we're going to think of it the same way. So we're trying to multiply to 90 and add to 1. So we're trying to multiply to 90, -90, and add to +1. 9 and 10, 9 and 10. The 9 is negative. So this is going to be 9x. This is going to be -9 root x, 10 root x. and that's going to be negative 10. So from here, I could take out a 9. I can take out a 9 root x. And from here, I can take out a root x because root x times root x is x. And then from here, I have 9, and then I have 10. This is going to be a negative 9. So I get the square root of x minus 9 and 9 root x plus 10 equals 0. So the square root of x minus 9 equals 0. I get the square root of x equals 9, x equals 81, because when you square both sides. And then over here, 9 root x plus 10 equals 0. 9 root x equals negative 10. Root x equals negative 10 over 9. You square both sides. I get x equals 100 over 81. There are 2 answers. Awesome, guys. Please do the video check-in. Write down any questions you have. See you in class.